as we're talking about the software development lifecycle and the pipeline for getting infrastructure and code changes into production, it makes sense a little bit to talk about how does HashiCorp and us, working with customers on Terraform related projects, how do we see customers scale Terraform adoption? So usually the way Terraform gets introduced in an organization is, the same way our co-founders thought of it as, hey, I'm having to manage all these different environments, and once in a while I forget to click something or I forget to run a script and things don't work. Is there a better way to do this, right? And luckily, there's a huge community and huge ecosystem around Terraform, so it's a pretty popular tool. To get started with, is completely free. It's an open source tool. You just download it and you write a config with it. You run a single command. The tool itself is a binary, and it executes that configuration that you provided it and creates resources in the cloud platform of your choice. But the challenge we see with scaling that is usually it's not sustainable for one developer or one operator to be running these commands from their laptop all the time, right? So there's some automation required around how infrastructure changes are managed. The same way we don't expect developers to be building software on their laptops, we don't expect developers to be running Terraform configurations, operators to be running Terraform configurations on their laptops either. So the way this gets realized is through the concept of what we could call a pipeline, right? Which is inputs go in on one side and outputs come out on the other side. When you start thinking about it, it looks very similar to an assembly line, because the same way on an assembly line, people have very specific roles that they play, very specific bits of manufacturing that they're responsible for. The same thing is what we want to realize with this pipeline. Developers are responsible for creating build artifacts that can be successfully deployed. The network team is responsible for ensuring there's network configuration that is going to, create a suitable environment for us to deploy our application in. And then maybe the operation teams today are responsible for configuring and setting up VMs that we deploy the code on that reside in the network that's been configured by the networking team. And that the pipeline of the changes that need to happen should look very similar to an assembly line, right? When you're trying to build a car, no one person is responsible for building the entire car. There's automation in place. There's specific things you're responsible for, your power tools that you have access to. That's exactly what we've tried to build with Terraform Enterprise and Terraform Cloud, which are our commercial offerings. The same way for automation, you need specific machine parts, right? Imagine if you had to design your own parts when you're building a car. No two cars would look the same, and there's no way it would pass any sort of quality check. So we want what we call machine parts, or these are validated, tested parts that we know when bolted onto something else will give us a functional car. So the Terraform Cloud and Terraform Enterprise provide a Terraform module registry where you can take bits of Terraform configuration that work and give you expected resources. An example could be, I have bits of Terraform that create a VM for me on which I run my .NET applications. So I can create a module out of this Terraform configuration, publish it in my module registry, and then other people can use it as a machine part, pull it down and build other things with it, right? If I've got this part that I pull down the module for creating a .NET VM, and then I bolt on another part that creates my database, and then I connect the two, and that way I have two validated parts that I know work, that have been published in a central location. I can pull those down and put them together into a working example. And that's just the beginning of possibilities, right? The VM and the database, you can combine and build these modules in, whatever your architecture desires. That's one of the beauties of Terraform, is using Terraform, you can manage resources, whether they're running on-prem, whether they're running in cloud, whether your application has resources across clouds, all of that. You can use these machine parts, the modules, and start building infrastructure. So that's one, I think, common practice that leads to scaling, is having these modules that have been tested and validated. And did you have any experience with your customer helping them build modules? I think that's something partners help customers a lot with when they're starting their cloud journey.
Yeah, and the registry is a great point, because we took advantage of some of the public module registry that Terraform provides access to, and looking at some of those things. So we know we didn't want to duplicate anything or recreate anything that might already exist. So our first pass is generally through the Terraform's module registry and looking to see what we can start from as a base. we take that and maybe we make it our own for the things that we're actually, looking to do for our purposes. And there, we also started building out a private registry as well. So, for our customer, we may start with a base module from the public registry. We tweak it, enhance it to fit the needs of the customer. And then we take that module and we put it back into a private registry. So then it's available to, us for other purposes or similar purposes. It's been a great experience so far. It's a nice little feature that Terraform provides.
Yep, and I'm sure people who work in assembly lines wish they could have parts that could be customized for their needs and waiting ready for them in the parts bin. But we're lucky to work in the world of software where that's an easy possibility. That's a great example. A lot of customers that are getting started out with Terraform will, because of that huge ecosystem, because of how wide the adoption is in the community, there's tons and tons of examples that are available that kind of show you what Terraform configurations look like. And you're able to go to our public module registry, find out what other people have published, use those as a starting point, and kind of tailor those to your organization's needs, which is exactly what you're describing, right? And the modules in the public registry have needs to serve the needs of basically the entire community, but you could take that and customize it. Maybe you prefer to use a specific type of encryption or a specific size of VMs or specific class of VMs, right? You can customize that, put that into the module and make that available as a whole unit that can be consumed as a little bit of an abstraction by people who are putting these parts together. I mentioned this already, but there's another kind of advantage with Terraform, right? Especially if you're working in, I mentioned hybrid environments. If you think about that assembly line, if you had people where only some of them had power tools and the others had to have manual tools to build these things together, that would block up the assembly line. Terraform kind of bypasses that problem because we have integration with not just the cloud environment, but any other resources. For example, with Azure, a common use case I see is, yes, we can use ARM templates to create resources in Azure, but IAM side of Azure, which is Azure Active Directory, there's no direct integration with ARM. For that, a lot of people end up using the Azure CLI or PowerShell and things like that. That goes back into that world of like, there's automation in some parts, but not in others. So Terraform is unique in being able to talk to Azure Active Directory and Azure Resource Manager. So we can, at the same time, manage the identity of the application you're trying to deploy, configure the resources for that application that you want to deploy. And we also have integration with GitHub pipelines and Azure DevOps. So we can go and configure the CI pipeline for the application you're trying to deploy. So there's automation throughout the assembly line, if you will, which is, again, super powerful.
I do like that layer of abstraction that you get, because these things are really, it's important, I think, to keep in mind. Terraform is that, the way I view it, it's that abstraction layer between you and the target cloud environment that you're working with, be it Azure, AWS, or whatever. And it's really just calling those APIs or features that that cloud provider provides to everybody. Terraform is making that an easier, more consumable means for you to get your work done. It greatly simplifies things. So but one of the things that we've come across, and it's interesting, I'd like your take on this. Say a cloud provider introduces a new feature, right? Or maybe a new API or a change to an API that Terraform is able to consume, or maybe not yet able to consume. The potential lag behind Terraform being able to take advantage of that new feature by the time AWS or Azure introduces it to it being ready and available in Terraform, how long would you say that wait tends to be?
Yeah, I think so. That's a common concern among people who are looking at Terraform as sort of this kind of product that's outside of the cloud provider's purview, right? You might think that since HashiCorp maintains Terraform, AWS may not be super interested in making sure we have feature parity by the time they go live with their APIs, but it's actually, they understand the wide usage and adoption that Terraform has in the community. So whenever they're launching new features, right, when they're creating new APIs, they actually work with us to make sure some of these features are available before the product goes GA. Or at the same time, right? It's a fast follower. If they make an announcement of specific features going GA, it's available in Terraform the next day. the reason for that is we're co-developing the plugin that Terraform uses to talk to that provider's API. So for example, the AWS provider lets Terraform talk to the AWS API. There's AWS engineers and HashiCorp engineers collaborating on that. And this is all open source. It's on GitHub. The other benefit of that is we know, if there's ever a new feature that comes out and there's wide community ask for it, and somehow, usually we're good about it, somehow we missed it and AWS missed it, community members will contribute that feature as a fix because all of the code is, again, available on GitHub as an open source item. And then finally, we have like the final fallback. If there are things that you built in CloudFormation, Azure Resource Manager, if you're already adopting that, or you think there are features that are available there that are not available in Terraform, Terraform can easily manage ARM templates and CloudFormation stacks. So we always have that as a safety valve. If you think there are some features that have not made their way to Terraform that are available in the cloud native platform, you're able to manage those using Terraform also. Looking into the future, one thing I'll point out is there's very interesting things happening in how the cloud providers surface their APIs for consumption, because they understand Terraform and other infrastructure management tools are key to every major cloud transformation program, right? They understand infrastructure as code is basically table stakes if you're trying to run infrastructure in the cloud. And they understand their external third-party tools that customers prefer to use, for example, Terraform. They're changing the way API changes get published so that Terraform or other companies, HashiCorp, other companies that are out there, can consume these API contracts that are published by the platform and then automatically generate integrations. There's interesting stuff happening in that area. AWS launched a Cloud Control API recently that is in preview. So it's not fully featured yet, but over time, their intention is all new features get launched with that Cloud Control API. And then we have the ability to generate automatically integrations with that API. So, there's no kind of manual code writing required by our engineers or theirs. We're able to just consume the API once it goes live. We're just able to use that and build integrations automatically. That is a little bit in the future, but this problem I think is going to get better and better because there's already tight integration between us and the big cloud platform providers, infrastructure providers. And in the future, that layer's sort of dissolving into just being able to automatically generate integrations there. So I don't think it's been a blocker for any of our customers, basically is what I'll say. There's specific features that you've tried and they're not making their way into the provider. Obviously, if you have the gumption to, you can go and update the provider yourself. But like I mentioned, we have the safety valve of just using the cloud native CloudFormation or ARM template or whatever resources there. Terraform will work with that very well too.
Yeah, and it's good to hear you kind of speak to that, because I think it's good information to share with the world. That was one of our concerns when we were first looking at Terraform and similar solutions, understanding how well you keep up with those different cloud providers, and specifically in our case it was AWS, and understanding that if there was a new feature we wanted to take advantage of, how quickly would Terraform be available, make that feature available to us. And we haven't had any issues with it. I've been pleasantly surprised by that as well. There hasn't been a need for a workaround or anything like that. But I think it was, we asked the question, you guys answered it, and it was great. We're happy with the response, just like the response you just gave. And I think it was good for everybody to kind of hear that in case they were wondering as well. Yeah, we haven't had any issues just yet.
We understand, right, that is a concern, and we work hard to make sure that doesn't become a real blocker or a problem, right? So that means our engineers are working with AWS engineers. We have product managers that work together with theirs to make sure for the marquee features we have launch day support. To your point, right? It shouldn't be a problem for most organizations.
Yeah, it's been good. It hasn't been a problem for us.
I think as we were talking through that, one thing that I was thinking about when we were talking about the assembly line earlier, right? There's different components that different people are building. I wanted to point out one of the features that kind of differentiates our commercial offering from the way the open source binary works. we have a concept of workspaces, and I think of it as a station on an assembly line where, you're responsible for doing your job or specific things that you're responsible for, whether it's, putting the door on or slowly slotting the engine, and whatever your responsibility is. The same kind of parallel applies to workspaces where you can manage who has access to specific workspaces in Terraform, and use that concept of this bounded box of a workspace to control which specific bits of infrastructure are managed by who. So what that lets us do is kind of split responsibility where, yes, we want the entire, top to down, the entire infrastructure should be codified and automated. But what you usually see is that networking and VPCs and things like that don't tend to change very often, right? So what we've seen customers do is take that and put it in one box and give access to a specific team. Maybe it's a networking team or the admin team or the ops team. They get access to this one workspace, and they're responsible for managing the networking bits. Whatever is required to run the application itself, so the VMs, the databases, any load balancer configurations, if you're in a cloud environment, that can live in a separate workspace or box that is under the control of the development team. What that lets us do is split responsibility, and then also give granular access where, yes, we trust the development team, but we don't want them to go muck around in the networking configurations. We will tell them, here's the subnets and VPC IDs that you need to use. That is exposed as an output from our workspace. The development team is able to programmatically consume that output, but they can't make any write changes to our environment because we restricted what their workspace has access to. They're able to consume these outputs, use them to modify their own infrastructure all day long. No blockages there, right? So because our eventual goal is to enable full self-service where the developers or the development team that's responsible for their code is also responsible for the infrastructure. That's a spectrum that's, I think, the North Star that people should be working towards, because that is what allows true velocity. But the development team manages their own infrastructure in their workspace, and there's kind of strict separation of roles and duties, and access is also managed on a granular level. And I'd be interested to see when you're working with your customers, did they have any concerns around, handing the keys of the kingdom, if you will, where you're able to go modify all these resources with automation to all these new people, whether it's developers or whether it's automation experts or consultants like you. Were there concerns around that, and how did you address those?
Oh yeah, there's concerns, especially I think everyone kind of is drawn to the networking bits and understanding as soon as, I've laid out VPC, subnets, et cetera, and I've got them to a point where they're working, they're solid, I trust them. And you mentioned the idea of workspace, and I have separated those out into their own workspace so they can be managed independently of the other workspaces that may exist. We do lock that down. So there's very few that would have access to, certain workspaces, network being one of the key ones. And we didn't give the keys to the kingdom, as it were. You may have rented a room in the castle, but you didn't get free run of the entire castle. And that part of it is it's made people, leadership certainly, a little bit more calm to the idea and more receptive to the idea of, okay, there is security, there's some protection here. Not everybody, I don't have my lower level, maybe developers with access to my very important, very sensitive networking components, and oops, I changed it and I deployed it, and now everything's broken. We have, gates and locks around all that stuff. So it's worked very well. And that workspace perspective that you talked about, it's helped us to define some boundaries around, it kind of goes back to who owns what. What is the ownership of these various pieces of things that we're auto provisioning look like, and who's going to be responsible for them. So we have been able to divvy it up at a high level from, these are networking components, these are security components, these are the individual application components, and look at it from that level. And then similarly, we've looked at it, from an AWS perspective. Here's our global stuff, here's our account level stuff, here's our application level stuff, and draw some hard boundaries around it and create workspaces, related workspaces for that work, and then manage access to those workspaces accordingly. So it's worked out real well. We like the structure, and it seems to fit in support of the things that we're trying to achieve.
Yep. I think another piece that I forgot to mention here, the enterprise product has single sign-on integration. So you mentioned access, and teams, if you were having to do that manually and go and configure your platform and allow people opt in into what teams they get access to and things like that, that could be a little bit of a pain. With single sign-on, and this is part of our HashiCorp's philosophy, is single sign-on is the source of identity, source of truth for who has access to what. So all of our tools, at least the enterprise versions, have integrations with your single sign-on providers, because we want to alleviate that operator burden of having to decide manually who goes in which team. We get all that information from single sign-on. All you have to decide is which groups from your Active Directory, your LDAP, or whatever single sign-on mechanism you're using. The operator only has to decide what team of that what group from there matches up to which workspace, and that way you're able to provide easy role-based access control and remove that manual burden of assigning individual members. Just by the virtue of them being part of a specific group in Active Directory, we're able to give them access. Maybe it's read access, write access, specific levels of access based on their role into workspaces. So that really helps with the thing you mentioned, where yes, you can rent the room. Maybe you can come in and look around and see what infrastructure is created, but you're not allowed to modify things, right? As a developer, maybe you need to come in and see, okay, what is the IP of the VMs that have been created, or where's the load balancer, what are the DNS entries that exist, but you're not allowed to make any changes. The dev lead of your team can come in and kick off Terraform runs and make those changes because we trust them a little bit more, maybe based on experience and things like that. So all that is very easy to manage with single sign-on with Terraform, but that is another kind of concern toward that contributes towards scaling, where if the right people will have access, it's a little bit easier to sit back and relax a little bit, because we have systems in place that are going to prevent people from making either too many changes or creating havoc, because we know we're using our single sign-on and allowing access based on that.
Yeah, and the fact that you support that feature and the various identity providers, it fit well, again, with another thing we were just trying to achieve. It felt well into the security posture that we already had in place, and some of the rules around this is how we access things. It folded in nicely to what we were already doing. So we didn't have any issues or concerns with that. It just kind of worked.